describe nature. When we want to describe nature, we must measure it. And in order for us to measure something, we have to have standards. For example, 1 meter, right? That is one standard. Or 1 centimeter, 1 kilogram, and so on. That are standards. Uh, in mechanics, we have only three fundamental quantities. They are length, mass, and time. The other quantities can always be calculated from these three fundamental quantities. For example, if we talk about density, right, rho, it is mass divided by volume, right? And mass divided by volume is actually mass divided by cubic length, right? And you see here, this is another quantity, and it can always be written in terms of the three fundamental quantities, okay? Another example is speed. Speed is length divided by time, right? Force is mass times acceleration. This is the Newton's second law, right? And acceleration is length divided by time squared. And again, you see that force can be written in terms of mass, length, and time, okay? So the most important thing here to remember is that in mechanics, we have only three fundamental quantities: length, mass, and time. And if you study later the course of laboratory physics 1, you will see that there are only three fundamental quantities that you will always measure in all kind of labs: length, mass, and time, no more, okay? Okay, now we will talk about the SI system. Uh, this is a system of standards. I think you know it from high school already, right? This is kind of a common language that we use in science, and it's like for length we have meter, right? For mass we have kilogram, and for time we have second. We have other standards not in the SI system, for example, yard, pound, inches, gallon, and so on. But usually in science, we do not use these standards, okay? And you can read our textbook for more stories on the units. This is optional, okay? Okay, the next thing that we should know about physics is the way that actually we study physics. Not only physics, but mostly every science. That is model building, okay? Model building is essential in the way that we study about nature, because in reality, as you can see from this picture here, nature or reality is something that we can never know exactly 100%, right? Uh, During the history of human beings, actually, at the very beginning, we did not have very too much accurate knowledge about the nature. We explain things in terms of gods and kind of that, right? And later on, we had a better idea of how things work. And together with them, our knowledge gets better and better and better. But at the end of the day, our knowledge is always approaching the truth, nature, reality, but we can never get there. There is always some gap between how things really happen and how we know about things, right? Uh, and all of our knowledge of physics are based on models. Models are ways that we describe nature, but it's not really how nature works. It approximately, it an approximation only. Right? Usually in model building, we start like this. We observe natural phenomenon, right? We see things, we try to understand it, we we build models. And the very first model is the word of God, right? That is also a kind of model of ancient people. They explain everything in terms of God, right? We have God that creates things, create rain, that create the sunshine. We have God kind of the moon and of everything else, right? We explain things by saying that gods do this and that. We have a lot of gods. That is also a model, but it seems that it doesn't work very well, right? And it doesn't give us uh, too much knowledge and too much kind of understanding of the nature. It's saying that God do everything. Uh, so the model of God doing everything can be said that it is obsolete, right? It is not right. It's wrong. And therefore, in order to get a better picture of nature, we have to observe it more and more, and we make better model, right? You can see here that the veritas here is kind of the truth, right? And the way that we know about it is that we build a model and then we make predictions, right? Make predictions, and then we have to check the predictions by different kinds of experiments. If the experiment's result turns out to be correct, it means that our model works very well. Otherwise, we have to rebuild a better model, and then we make another predictions, and so on and so forth, right? And by doing this over and over again, we get closer and closer to the truth of how nature works. That is the basic way that we learn about nature, right? We have some models that are wrong. We have models that used to be the best, but not but still useful, right? And we have models that currently best fits reality, the models that we are using. I will give you some examples later on. But the basic thing here is that nature, how nature works, we can never know exactly. We can only know it to a good approximation. And the way that we study nature is by building models, right? And make a better one and a better one. And as you can see here in this picture, if you build a very beautiful model, but it doesn't fit reality, it means that your model is wrong. No matter how beautiful your model is, if your predictions are not correct and not confirmed by experiments, your model is wrong. That is why I say physics is an experimental science. Okay, it is not a belief. We have to check it. And if it is correct, your model is correct in some limit. Uh, this is an example. It is regarding to astronomical model, right? And it is quite, I mean, I think everyone knows about it. We have two pictures here, and this one is called geocentrism, a model long time ago. It was believed to be correct for many centuries, that the earth is at the center of the whole universe and everything else moving around it. The sun is moving around the earth and so on. Right? It was developed by Aristotle, Ptolemy, right? And it was beautiful because according to this theory, the earth was the center of the whole universe. And we human beings are at the center of our universe. This is very beautiful, right? But then there were observations, astronomical observations that showed that this picture cannot explain some facts, right? How stars are moving, how planets in the solar system were moving. It cannot explain, and it turns out to be not quite correct. And the correct one was later on developed by Copernicus, Bruno, Galileo, and Kepler, and so on. That's called heliocentrism, right? The Earth moving about around the sun, right? And the sun is the center of the solar system, and so on. As you can see here, this wrong picture, the wrong model, was used for more than 1,000 years, okay? 2,000 years. So this is a wrong model, and this is the better one, the correct one. Okay? We had observations and experiments that point out that this model is correct. Another example of models is the model of matter. Okay, you can see here, very long time ago, in ancient Greece, we had a philosopher with a model of atom. They call it atomos, right? This is the very first model of how things are made, right? According to these philosophers, our world, everything is made of the atomos, something not sliceable, right? It has no structure. It is the smallest, most fundamental, most elementary particle. You cannot slice it, right? That was the first model. But later on, you see here the time, right? 1897, Thomson found the electrons. That was called the alpha radiation. They found the radiation from the atom of some substances, right? So it seems that there's something inside the atom, right? And that was later on called the electron. The electron. And they built another model. Actually, Thomson built the pi model of atom. So atom is not something like this anymore, but it is like a pie, okay, with some peaks, with some small points here. It is electron, right? But later on, Rutherford, a student of Thomson, found the nuclei, right? The nuclei is something very small with most of the mass of an atom. So you see now the picture is different, right? It is not like this anymore. It is like a solar system with the nuclei at the center. Most of the mass is in the nuclei, and electrons moving in orbits around it, like a small solar system. Right? And at that time, people believed that the nuclei is the most, fundamental particle, and it cannot be divided in anymore. Later on, we know that nuclei are made of protons and neutrons, but we did not stop just there. Later on, we found out that protons and neutrons are made from quarks. small particles with fractal charge, and so on. These are the pictures, and you can see here, right? This is the current model of matter that we know so far. Maybe in the future, we will find out new things about it, and we will build better, more accurate model. As you can see from here, this is the way we learn, we study nature, right? Step by step, build models, check it, get a better one, and move on. This is the basic way in physics. Okay, now I will move on to one important part. This is called dimensional analysis. This is a technique very useful and powerful, as you will see later. Okay, so dimension, this is a Vietnamese word for it. Sometimes I will give you the Vietnamese word because it is not quite familiar to you. So dimension, it means dimensional analysis. Okay, so what is dimension of quantity? Dimension, thứ nguyên, okay, dimension, thứ nguyên. Dimension shows the physical nature of that quantity. Okay, quantity, đại lượng. Okay, and the notation you use to describe the dimension is the square bracket like this. Okay, you put it in a square bracket, and it means that you are saying about the dimension of that quantity. Okay. In mechanics, we have three fundamental standards: length, mass, and time. And we use the capital L, M, and T to describe the dimensions. Okay. Now, the dimension of other quantities can be expressed through L, M, and T, as in this picture. Example. For example, if you want to find the dimension of velocity, right? Vận tốc, you will put the square bracket over it, and you will see that it will be length divided by time, right? Or you can write like length times time to the -1, like this. Okay, and you say, so this is the expression, mathematical expression. You can say it like speed has the dimension of length over time. Okay. Another example is density. Right? Density is defined as the mass of a unit volume. Right? It's like 1 cubic meter or something. Right? So density is calculated by dividing mass over volume. So the dimension of density is mass divided by the dimension of volume, right? And the dimension of volume is length cube, right? So that is mass divided by length cube. This is the dimension of density. Okay. And the dimensional analysis can be used to check very quickly whether an expression is correct or not, right? So this is an example, right? If you have an expression like A is equal to B, I mean in physics, right? It means that the dimension of the left and the right side must be equal. If they are not equal, then the expression is wrong. For example, if you have on the left 1 kilogram, on the right you have 1 meter, and you put an equal sign in between, this is wrong, right? You cannot compare 1 kilogram and 1 meter because they are of different physical meanings, right? On the left, if kilogram, you have mass. on the right, you have 1 meter. Its length, mass and length are different of different uh, physical uh, um, kind of fundamental quantity. Therefore, they are not equal, right? Uh, Another thing you can see here that if you have quantities of the same dimension, then you can add, count, or subtract 2, right? So if you want to add 1 kilogram and 3 pounds, it will be okay. Of course, you should convert them into the same unit before doing it, but at least they are of the same dimension, therefore you can add them together. Or you can subtract 2 meter by 3 centimeter, that will be okay. But you cannot do something like this, 1 kilogram minus 1 centimeter. This is meaningless, right? They are of the different dimension, different physical meaning. Or 10 meter per second plus 10 seconds, this is also meaningless, right? This is kind of speed, and this is time. You cannot add speed and time. Okay? That is the meaning of dimension in physics. However, you can multiply or divide quantities of different dimensions. Adding, subtracting is impossible, but multiplying and dividing, it is possible, right? For example, speed is distance divided by time, right? And you see that distance has the dimension of length. Time has the dimension of time, right? You have 2 meters per second. This is speed. That would be okay. Or you can multiply, like mass is equal to the density times volume, right? So they have different dimensions, but they can divide. You can divide or you can multiply them. So this is to show you the meaning of dimension in physics, right? When we mean dimension, actually we mean something, the physical meaning of that quantity. Okay? This is an example. This is an example to show you the power of dimensional analysis. Imagine that you drop an apple from some height h, okay, with initial speed 0. You don't give it any initial speed, just drop it. And now you care about the time, right? You care about the time. How long would it take for the apple to reach the ground? Without any knowledge about kinematics, you can still do something with just a dimensional analysis. What you do here is you write an expression like this. What does it mean? This means, okay, I will point it out at the beginning, okay? This is kind of a hypothetics, right? You don't know yet what time depends on. So you can say that, okay, well, the time should depends on G, right? The gravitational constant, gia tốc trọng trường, okay, G, okay. And then you may say that, okay, it seems that it depends on H, the height, right? Maybe you drop it from a higher position, it takes a longer time, right? So it should depend on the height. And finally, you may think that the time will depend on the mass of the apple, right? You don't know yet, but you would say that maybe it depends on mass also. Anything else? Nothing else, right? Nothing else. So these are things that the time may depend on, but you don't know exactly uh, how how is the dependence, and therefore you write it in this form, which k is some coefficient. This coefficient doesn't have any dimension, just a number. Okay, g to alpha, h to beta, and m to gamma, and we don't know yet a alpha, beta, and gamma. We have to find out using dimensional analysis. Okay, the key concept here is the left and the right sides of the equation must have the same dimension, as we said on the previous slide, right? If a is equal to b, they must have the same dimension, otherwise it's not correct. Therefore, we will find the dimension of the left and the dimension of the right and compare them. That is the technique. Okay, on the left we have time, and the dimension of time is time, t, capital. And on the right, you have to calculate the dimension of it. The way is that the way to calculate it is shown in this expression, right? The dimension of the whole thing is equal to the dimension of g to alpha to the power of alpha, and then times the dimension of h to the power of beta, and then times the dimension of m to the power of gamma. Okay, remember that k is just a coefficient, and a coefficient is just a number. A number doesn't have any dimension. Okay, okay. And now, what is the dimension of g? G, if you remember, it is 9.81 meter per second square, right? Meter per second square, you can look at the unit here and you will see it very quickly that it is length divided by t squared, okay? This is the dimension of g, okay? What is the dimension of h? H is the distance, the height, and the dimension of it is length, okay? L to the power of beta. And finally, mass, m, has the dimension of mass, which is m capital, the big one here, okay? Okay, now you will see that we have L to the power of alpha, and here we have L to the power of beta. Finally, you will have L to the power of alpha plus beta. For T, you have the power of minus 2 alpha, and for M, you have gamma. Now remember, the left side and the right side must have the same dimension, and we will compare it, okay? The dimension on the left of the left and the dimension of the right side. And you will have a system of equations, right? On the left, t, you have plus 1, and therefore you see that on the right side, you have plus 1 is equal to minus 2 gamma, 2 alpha here, right? On the left side, you don't have L. You don't have length on the left, and therefore alpha plus beta must be 0. Similarly, on the left side, you don't have mass. On the right side, you have mass. It means that gamma must be 0. Okay? Solving this equation, this system of equation, you will have the result here, right? And finally, you can write down that T is proportional to g to the minus 1/2, h to the power of 1/2, and m to the power of 0, right? Or you can write out t is equal to square root of h divided by g. Starting from nothing, okay? You can see starting from nothing, you get a very good result. Of course, you don't know the coefficients. You don't know the coefficients, but this is already a very good estimation result. The correct expression is this. I will write down. T is equal to 2h divided by g. So this is the correct one. And in order to get this, you have to learn about kinematics, động học. Okay. And this result is extremely good because it requires nothing but the knowledge of dimensional analysis, right? Okay. Uh, a tip, a trick for you to get the dimension of some quantity very quickly is you can tell it from the unit of that quantity. For example, rho, right? Rho is the density. The density has the unit kilogram per meter cube, right? Therefore, you can write down like uh, meter divided by length cube. That is a quick way to find out the dimension of some quantity. If you don't remember the unit of the quantity, you can try to write down the definition. This is the definition of rho, right? And from the definition, you can also write down the dimension of that quantity. Okay. Okay. Now we will stop for a moment, and I would like you to go to our web page and do one uh, quiz in class. I will open it right now for you. You will have 8 minutes to finish it, and I will take that score uh, to. You wait for 1 minute. I will open right now the quiz. Okay, it is here. Now I will open the quiz for you. Okay. Okay, now you go to our site on FHQX, our group, okay, and scroll down. You scroll down, you will see chapter 1, which we are studying now. And right below, you see quick quiz number 1. You click on it, right? Click on it. And then you have 8 minutes to finish it. This is about dimensional analysis, right? Just follow my example. You can do it. Okay. This is my example. So all you have to do is to follow my example and do that quiz within 8 minutes, and you get the first quiz. You get. Okay. I will see you back in 8 minutes.
Distance traveled in
Some students are still finishing the quiz, so we will wait for them. When we study offline later, we will not do quiz like this because we don't have time. So maybe I will give you small questions or small problems to solve in class. Okay. Okay, I can see that we had some students here started the work very lately. Okay, for those who are still doing it, keep doing it. Okay, I will continue my lecture. As you can see here, we have most of you started at 2:14, right? So it's already like 12 minutes. So I will not wait for the students that started too lately. Okay, someone started it very recently. I cannot wait for you. Therefore, I will continue my lecture for the students. Just take your time. Okay, now I will talk about conversion of units. This is a basic things, right? You, I think everyone knows about the difference in units. For example, between meter and centimeter, right? You have 100 centimeter, it is equal to 1 meter. If you are 0.2 kilogram, it means you have 200 grams, right? So this is very basic. I like to ask you to read the conversion of units in the textbook by yourself. This is very basic. But what I want you to take care of is when you do the calculation or when you solve some problems. First thing is that you have to look carefully at the units given in the problem. Whether, for example, you are given with some distance, right? Pay attention to the unit of it. Whether it is given in meter or in centimeter, for example, right? And then it is better for you to convert them into the system, international system units before solving the problems. That is a good practice. So you don't use centimeter, you don't use gram. You can at the beginning, to be safe, you convert them into meter to kilogram and then do the calculation, right? And you should always check units when you plug the numbers in your expression. For example, you solve some problem, you get expression in terms of uh, different quantities, and then you plug in the number. You should check for the units of the numbers also. Right? Okay, now we move on to another technique. So previously we learned about um, dimensional analysis, right? We now talk about estimation, right? Estimation and order of magnitude calculation. These are two related techniques. Okay, so I think first of all, I would explain what is estimation, right? And then I will talk about order of magnitude calculation. This is an example of estimation. So estimation is very important in physics, and I think in other sciences too. What is an estimation? Estimation is the technique that you can get a quick answer, usually without calculation or with a very little calculation, to get an idea of how big or how small something is. Right? That is not a correct number, it's just an estimated number, but it is accurate enough for your purpose. Okay, that is estimation. Ước lượng. Uh, for example, you can estimate the number of hair on your head, right? Or you can estimate, for example, if you have many ping pong balls, right? How many ping pong balls you need to uh, to put it fully inside your room. That is an example. You don't have a correct number, but you can estimate it. So in this example, you can find in the textbook. This is estimation the number of breaths you take during your lifetime, right? So if you look at it carefully, you can see many assumptions. Why we need assumptions? Because we don't have concrete numbers, right? We don't know how long people live, right? Therefore, we need some assumption, just an estimation. For example, here we take 70 years, the lifetime of a human being, right? That is acceptable, right? And therefore, later on, we find the approximate number of minutes in a year because we assume that we have 10 breaths per minute, right? Where do we get this number? We get it from our observation. You can try, right? You set your timer and then you count. For example, at 9, 10, 12, or 11, something like that, right? You can count how many breaths you take in 1 minute. Why should we choose 10? Because it is easier for us to multiply, right? When you multiply something by 10, it is easier and it is a good estimation. Therefore, we take 10, right? And then you would need the number of minutes in a year, right? You look at this expression, you will see that we have many estimations. For example, you have 1 year, you have 400 days in a year, you have 25 hours in a day, and you have 60 minutes in an hour. You can say that, oh, this is not the correct number. It is 365, right? But the problem is they are not very different from each other from the point of view of estimation. And therefore, you should take a number that is easier for you to multiply them, right? And therefore, this is why they take 400. And this, the number of hours in one day, they take 25 and not 24, because if you multiply 25 by 4, you get 100, right? And this is the reason why they take 400 here and 25 here, in order to do the multiplication quickly. That is the meaning of estimation. You don't need a correct number, you need an estimation, right? Okay, so multiplying them and you get 6 times 10 to the power of 5 minutes. And then in 70 year, you multiply this number by 70 and you get this number, right? Okay. And finally, you multiply the minutes of your lifetime with the breaths you take in 1 minute. And finally, you get 4 times 10 to the power of 8 breath. So this is an estimation of the breath you take in one lifetime. Okay. Now, you will see that if you change the number 70 here with the number 80 here, right? So if you take another assumption, you take 80 years as the lifetime, the answer that would be finally, it will be 5 times 10 to the power of 8. So if you repeat everything, but changing 80 years, changing 70 years by 80 years, you get this number, okay? So they are similar. They are similar. So this is an example of estimation, okay? Another example is to estimate, for example, the thickness of a book, of a page of a book, okay? Let me see, for example, I have here a dictionary, okay? I have a dictionary. Let me look at it. This example is not because I don't know the number of pages, okay? Let's take another book here, and let's estimate the thickness of one page. I would see that the first thing I should do that I check the number of pages in this book, and I can see that it is 850 pages, 850, 850, okay? And then I should estimate the thickness of the whole book, right? So estimation, I don't have any ruler, but I guess it is about 5 centimeters, it's like 5 centimeters, right? And then I divided 5 centimeters by 850. It is better that I take 5 divided by 800, right? And then I will get the number, right? Let me do it quickly here so you can see it. For estimation, you don't need the correct answer, the accurate number. You just need a good estimation. And okay, you have calculator here. You have 5 centimeter, and you divide it by 800, and you get this number. What did I do wrong, right? I forgot that, okay, we have 800 pages, but we have 400 actually paper, right? And therefore, I have to divide it not by 800, but actually it is 5 divided by 400. This is number of single pages. Right? And this is my estimation. It's about 1/100th of a centimeter, right? This is my estimation. That is an example of what estimation is, okay? Okay, now how to estimate the number of hair on your head. One technique is that you can look at, for example, a small area like 1 square, 1 centimeter square, right? And then you calculate how many hair are there, right? And then you can think of your head like half a sphere, right? Half a sphere. Nửa cái cầu. You can think like that. Your head is like half a sphere. You have the formula for the spheres um, area, right? You calculate the area of a sphere with the radius like this. You can estimate the radius of your head, and then you calculate the area of the sphere divided by 2, and then you multiply by the number of hair you count in 1 centimeter squared, and then you multiply that. That is one way to estimate how many hair you have on your head. Another example is that how many ping pong balls you need to put it full inside your room, right? You can estimate your room's volume, like 3 times 4 times 4, right? And then you imagine the ping pong ball as a box. It is easier to think of them like boxes, right? With the or even not boxes, yeah, square boxes, right? Like small square boxes, and then you can estimate. You divide the volume of your room to the volume of each ping pong ball. In that way, you can estimate the number of ping pong balls you need. Okay? So that is what estimation, right? Estimation to get the best number from the least information. Right? Another example of estimation: how many gas stations are there between Saigon and Vũng Tàu? Can anyone estimate it? I will give you some bonus. Gas station, tạm xăng đó, between Saigon and Vũng Tàu. How many gas stations? Can anyone answer it? Give me an estimation. Please raise your hands if you want to answer it. You get some bonus. Any answer? How many gas stations between Saigon and Vũng Tàu? Okay, you are moving from Saigon to Vũng Tàu for a day trip, for example. How many gas stations can you see on the way? It's just an estimation. Just and have to be too careful about which way, which information. What way I will take. Right, Minh Khôi, please.
Yes, Saigon to Vũng Tàu have
96. Okay, thank you. Any other ideas? Nguyễn Hữu Phước, please.
Hello, teacher. I think about 80 gas station between Saigon and Vũng Tàu.
Thank you. Any other ideas? Hồ Nguyễn Công Hậu.
Hello, teacher. I think have 90 gas station.
Mm-hmm.
Yes.
Thank you. Wow. I will give some bonuses for all of you because you answer my questions. At least you tried. I think that is a reasonable estimation, but I would like if it was me, I would say I think about 50. I think it's about 50, right? Because in my opinion, the distance between Saigon and Vũng Tàu is about 100 kilometer, right? It's an estimation. It's about 100 kilometer. And now we should estimate the distance between two gas stations. What is the distance? If you put one gas station every 1 kilometer, it seems not reasonable, right? Because if you have one gas station here and another gas station here, I think that you would not get a lot of people coming to get a gas. So usually you put a gas station not very long away from another one, but not too close. And in my opinion, it's about 2 kilometer or 2.5 kilometer. That will be a reasonable estimation. And therefore, I estimate that, okay, let's say 2.5. And we have the distance 100 kilometer, right? Sorry, 100, 100 kilometer. 100 divided by 2.5, I would have 40 gas stations between Saigon and Vũng Tàu. That is my estimation, which is about half your number, okay? That is estimation. I don't know correctly. I don't know everything about it, but that's just an estimation. And I think that about 40, 50 is more reasonable than 100. Okay, that is an example. Okay, thank you for engaging with my questions. So these are some examples of estimations, and good physicists have very good abilities of estimation. For example, Fermi. Fermi is one of the biggest physicists in the world, and he earned the Nobel Prize. And during one exam, he asked his students to estimate the number of piano tuners in New York. Piano tuner is the person that is, kind of tune the piano so it plays correctly, right? And he asked his students to estimate how many tuners are there in New York. And actually, he made a very, very accurate estimation about it. So estimation is very good and is very important for everyone. If you cannot calculate it correctly, at least you have some idea of something. Oh, Võ Anh Hào, please. Võ Anh Hào.
Dạ em thôi.
Yes. I see you are raising your hands. You have questions or anything?
Dạ em bấm nhầm với thầy.
Okay. Right. Another example of estimation is that you estimate the money you have to pay for electricity based on the devices in your house, right? Calculate how many house, what is the power of it, công suất, what is the power of the lamp and the refrigerator, what is the power of it, and what is the power of your cooker, and so on and so forth. And then try to estimate how much money you have to pay per month for electricity bill. That is one thing, very practical, right? And everyone should be able to do that, because sometimes you get a bill and it is extremely high, right? It is unreasonable. And if you have a good ability of estimation, you can have a better picture of everything. So that is what estimation about. Okay. After this class, I will give you some problems as homework, and I will ask you to do some estimations. The homework will be given on Thursday. Not today, not today, on Thursday. So on Thursday, you should check the page. You will see that on Thursday, some problem appears and the quiz at home appear. About one week to do it. So please check later. Check your class page work and the quiz at home. Not forget it. In weeks, I will remind you with some message, but later on, I will not remind you, but you have to check it every Thursday. Okay. So you have homework and you have quizzes to do at home. For quizzes, usually you have 30 minutes approximately, and you have usually 10 questions. For homework, usually you have 2 or 3 problems, and you can solve it during the whole week. Okay, so please take care of these steps. Okay. Okay, I think everyone else had finished the quiz in class. Now I will come back to discuss more about dimensional analysis here. Okay, this is the question I gave you in the quiz, which are incorrect, right? So in order to check the correctness of these expressions, all you have to do is to find the dimension on the left and the dimension on the right. For example, here, x on the left has the dimension of length. On the right, you have 1/2. 1/2 is just a number, okay? A and t. A is acceleration, and the unit is meters per second squared. The dimension of a times t is equal to the dimension of a times the dimension of t, which is L divided by t squared times t, which is L divided by t, right? So now you see that on the left you have L, on the right you have L divided by t. They have different dimensions, and therefore this equation is incorrect. Okay. Similarly, you can do the rest. Okay. Okay, so I gave you many examples about estimation. Okay. Now let's talk about order of magnitude calculation. Ước lượng theo bậc độ lớn. This is also estimation. But this is when you do the estimation, you only care about the order of magnitude. For example, when we estimate the breaths taken during your lifetime, you got the number 4 times 10 to the power of 8, right? You can write this number as 10 to the power of 9. And the order of magnitude is 9, okay? Bậc độ lớn. So you don't care about whether this is 4 or whether this is 5. What you care is the power of 10. So in this case and in this case, you have 10 to the power of 9. And 9 is the number of order of magnitude, right? So when we do estimation in terms of order of magnitude, what we care is the power here. And therefore, if one student estimate the number of breath and get this number, another one also do another estimation and got this number because they took the time differently, right? But if you turn it into the power of in the order of magnitude, you will see that their estimations are the same, right? In terms of power of magnitude. And therefore, how we can write it like that? this is some rules that you should follow. Right? The first thing is that you write the number in scientific notation. So what is scientific notation? It is A times 10 to the power of B. Okay, A is the multiplier. For example, here you have 4 times 10 to power of 8, right? It is exactly the same here. And then you compare this multiplier with the square root of 10. The square root of 10 is about 3.1, right? 3.2. And look, if A is less than this, then you would say that X is of the order of B. So you forget about A here, right? However, if the multiplier is larger than 3.16, you would add 1 to the power here, right? And you say X is of the order of B plus 1. This is tilde, and this is the expression. You read this expression as X is of the order of B plus 1, okay? For example, this number is of the order of -2. This number is of the order of -3, and this number is of order of 3, okay? So please remember that estimation is different from order of magnitude calculation, okay? Estimation is what I explained you. However, usually when people do estimation, they prefer to do an estimation using the order of magnitude. In that way, the result looks nice, right? Because as you see here, right, we have number which is 4, and here we have another number which is 5. Both of them are larger than a square root of 10, and therefore I think it's nice, more beautifully. It's more beautiful if you just say that, okay, my estimation is the power of 9. Okay, okay. So this is just a way of expressing your result. Okay, it is not estimation. The order of magnitude calculation is a way of estimation, but is not all about estimation here. Estimation is larger, and order of magnitude calculation is one technique in estimation. Okay. Okay. We have about 10 minutes, so I cannot cover the rest of the lectures. But what I want to say here is that you should read the textbook to know about significant figures and how to write the results the correct way. Let me cover it quickly. For example, right? The first thing here is that you have to remember every number in physics are obtained from measurements. And therefore, the numbers in physics is different from numbers in mathematics. An example here, okay? If I ask you to measure a distance, for example, from the front of my desk to my monitor, okay? I ask you to measure this distance. If you give me this number, 0.51 meter, another one gives me this number, and another one gives me this number. So what is the difference here? From the mathematical point of view, they are not quite different, right? They are different, but not very important. But in physics, this means a lot, because if you give me this number, it means that you use a ruler, right, with the smallest division 1 centimeter. Right? Therefore, you can measure it up to 1 centimeter. If you give me this number, it means that your ruler, the scale, is down to millimeter, right? And this number is unbelievable. This is impossible, because if you can give me this number, it means that you can measure the distance to the accuracy of the distance of the diameter of atoms, đường kính của nguyên tử. Okay, this is 10 to the power of minus 10 meter, the angstrom, that is the diameter of atoms. Therefore, this is impossible. This is not correct. Okay, so that is the difference between mathematical and physical numbers here. So please read the text to know about significant figures. Okay, as you see here, significant figures include first estimated digits, right? When you measure something with a centimeter ruler, you get this number. This is, for example, this number has 2 significant figures, right? We have a lot of rules and so on, but I ask you to read in the textbook, maybe in Vietnamese, maybe in English, but we have all of the rules here. Some of the rules, if you multiplied things, right? If you multiply things, then you have to use the significant figures in the result, the same significant figures as the less one that you had. For example, here, you know that pi, you can have many number of figures of pi, but actually when you measure the distance r, the radius, you only get to 0.1, 0.2, sorry, 6.0, right? You have 2 significant figures here. 6.0, 2 significant figures. Therefore, there is no reason for you to take a very accurate number of pi to put in here, right? And in the final result, you see that we have 2 significant figures in the result. In the textbook by Survey and Jewett, usually all numbers, when you do problems, all numbers are given with 3 significant figures. And in the result, you should keep only 3 significant figures, right? When you add them together, you should see that we now care about the how many figures, I mean decimal places you have here. If you add 2 numbers like this, there is a rule that you should keep the decimal places of the least one. Here you have only 1 decimal place, right? And here you have 3 decimal places. So when you add them together, the correct way is to keep just 1 decimal place here. How to understand this? You can think of it like you have 2 distance, right? And then you want to add them together. The first distance, the first length, for example, this is a meter, right? The first length you measure to the accuracy of centimeter, right? And the other one you can measure to millimeter. So there are some arrows in the 2. And when you add them together, just keep the one with the larger arrow. That is one way of thinking about this rule, right? When you add something very accurate with something not accurate, your result will be not accurate, right? And therefore, when you add numbers with some decimal places, remember this rule, okay? So all of the rules are given in the textbook. Please read them carefully. This is another example of the wrong way of, writing some number. So if you write something like this in an estimation or in some calculation, it means that you have 1, 2, 3, 4, 5, 6 significant figures. Right? and I do not believe that we can do a prediction. We can make a prediction with 6 significant figures to single person. Right? This is impossible. A better way to write this result is that you can write like in the scientific notation. For example, you write 2 times 10 to the power of 5. Okay, you can write it like this. And writing like this means that you have only one significant figures. Right? So the numbers are more or less the same, but the way we write it down means a lot. At least the number of significant figures, right? This is the scientific notation. We use the power of 10, right? For example, if you give me a length of 100 meters, it is not clear how many significant figures in this number, right? However, if you use this way of expression, I would see that, okay, you have only one significant figures, right? It means that you have a ruler that you can only measure to 1 meter, 2 meter, 3 meter, and so on. If you give me this length in this form, I know that you can measure to the accuracy of 1/10 meter, because here you have 2 significant figures. If you give me the length in this form, I would know that you have a ruler, right, with the accuracy 2 centimeter, because in this case, you can measure to the accuracy of every centimeter. If you multiply, you see that it's the same mathematically, right? 1000. But in physics, it is they are different depending on the way you express them. And therefore, scientific notation is a way to show the accuracy of the measurements, right? Every numbers, all the numbers in physics are obtained somehow from measurements. And therefore, the way we write down the number of significant figures is very important. Okay. And therefore, when you do some problems, solve problems and so on, you should take care of the number of significant figures and so on. You don't just type with your calculator and you write a lot of figures. That is nonsense, right? For example, I ask you to calculate the speed, tốc độ. I give you the distance, like 10 meters. Okay, I give you time, 2 seconds. So it means that you have 2 and 1 significant figures, and then when you divide it, take care of the number of significant figures in your final result. Okay. You should read more about this in the textbook about significant figures and how to write it correctly, because it is very important for engineers, right? Engineers should always write down the correct way. Okay, this is very important for engineers. And on Thursday, I will give you homework, and in that homework, I will ask you something about how to write down numbers in the correct way. Okay. Okay, that is all for our class today. Finally, I ask you again that on Thursday, okay, on Thursday, maybe in the evening of Thursday, I will post homework and quiz to do at home. So please check them and do them as I asked. Okay, do not forget it. Okay. Any other questions? After the class, I will post the videos recording and the lecture notes on our page, so you can check it later. If no other questions, see you next week. Let's call it a day. Goodbye. If
Bye lecture.
Goodbye,
Okay.
teacher.
goodbye.
Bye teacher. Bye teacher.
Goodbye, teacher.
Bye teacher.
Bye. Have a nice day.